Hi, Olivier here. Today, I want to show you how I'm building a device twin with the Particle Cloud and the Particle device here. So, device twin is a concept of a digital representation of a physical device in the cloud. It allows you to interact with a physical device even if it's not connected, and also to structure the way you exchange information. You can decide to go very raw and just exchange events, sending a message, receiving a message, and then you implement your own logic on both sides with a convention of your own. Or you can leverage a set of features that an IoT platform like Particle offers to make more sense of the data and simplify your interactions with the device. So here I have this little boron device. It's connected over cellular. It has a little temperature humidity sensor attached to it, and I'm building a smart thermostat. Pretty straightforward, right? Let me show you in terms of code how that looks like and how I'm building that digital twin based on the main artifacts and functionalities of the Particle Cloud. As a little disclaimer here, the notion and the name device twin, is something that I'm using. Particle does not use a device twin name as a feature, but has a set of features that I'm going to play around to create a device twin. But the feature I'm going to use are the events, so publish, subscribe of events, the variables, very interesting concept that Particle has, the function. This one is going to be very anecdotal, but very interesting in the concept of device twin. Last but not least, a new feature on the Particle Cloud are ledgers. I will synchronize a desired and reported states between the device and the cloud. So let's go for it. The first one is publish, sending an event, receiving an event. So publish and subscribe. It's very straightforward, as you'll see, and that's certainly the basics of anything IoT. Sending a message, receiving one. You have control over that lower layer on the Particle Cloud in a simple, one method call. In my C++ file, I need to include the device OS APIs library, which is particle.h, right? First line of any Particle application file. And the device OS APIs are basically all the functionality that you get from the device OS, the firmware that is powering your Particle device and that you run your application on. Let me skip to the interesting part here. My application has a setup function and a loop. In the setup, the first thing I need to do to be able to communicate with the cloud is to check that I'm connected, right? I know I'm connected, so useless to start trying to communicate with the Particle Cloud if you're not connected. One call here, and you know if you're connected or not. You'll notice that I didn't do any Wi-Fi configuration or cellular configuration. Device OS takes care of that based on the configuration that's been set, in my project here. If I wanted to have Wi-Fi, I would add a connectivity properties file, and I will allow my device to be connected to Wi-Fi. Here, I have a boron that has an eSIM on it, and it will connect over cellular. I did provision my device the very first time. Now it's connected each time it turns on. All good. Thank you, Particle. So Particle Connect, I am connected. I will move on. I will go back to some of these other things happening here. The one thing I'm interested in is this call here, particle.publish with the name thermostat-online. So this is me saying from the device, hi, I'm alive. And it took that one line to publish that event to the Particle Cloud. If I look at the console, let's look at our device. It should be here. And here I see events I just received recently after turning the device on. Let me actually reset it so you'll see the events coming up. Device will turn on. It's blinking green, bringing up device OS. It will then switch to blinking blue or cyan in order to connect cellular. Boom, it connected the cellular, and now I can see events arriving. First few one are coming from device OS itself, and here it's my application sending its messages. I've got this thermostat online event that arrived that was sent from that setup function here. Okay, so publish allows me to send that named event, but eventually I can enrich with the body with content that could be, a value for a sensor, for example, or another piece of information. If I wanted to listen from that device to some message, some event from another device or from the cloud, I could use a subscribe function, and that will allow me to receive an event or a message, right? To publish, subscribe. It's a one-to-many feature, very interesting, and certainly at the core of anything else you can imagine on the Particle Cloud. Let's get into a little bit more sophisticated function, which is the variable. So the variable is that other feature that allows me to share information from the device to the cloud. In my case, I want to expose 3 variables. And these variables for now are local to my C++ file, and they're proper to my application. The scope of these variables is the application on the device. What I can do with the particle variable feature is extend the scope of these variables to the cloud. So here I have last reported temperature, humidity, and pressure, 3 double variables on my device. And if I look at this next call in the setup function, I'm declaring a variable called temperature, and that will point to my local last reported temperature value. When I do that, the variable appears in the console, and so is now available in the cloud. And you can see down here, temperature of type double, and I will be able to pull it from the cloud. So the device exposes the variable, which is now available on demand to the cloud application. Very powerful. I don't need to send data all the time up to the cloud. I make it available, and the cloud will retrieve it when it needs it. What I've done as well here is that each time I update this value, I, in my loop function, get the sensor's information. I check if the values have really changed enough for me to update them. If that's the case, I'm publishing an event to tell the cloud, hey, I have new temperature and humidity and pressure variables. They've been updated. Do you want them? Do you need them, right? And on the cloud side of things, I will see that event. And you can see here thermostat sensor data updated. I guess if I blow on the sensor, it will change. Let's see. So I change the data. Boom, I received that new event telling me that, hey, I have new values, right? So I will go down here to temperature and do a get. And here I'm getting the last read of that temperature. So it's 24 something, right? If I get it again, it will change a little, 24.11, okay? So I can get the temperature at any time from the cloud. It will give me the latest registered value or recorded value on the device. Pretty powerful, right? Same thing for humidity and pressure. So we have the events, we have the variable that I can pull. The third one is functions. I can expose a local methods or function from my device to the cloud for the cloud to call. So now I have a bridge that is very powerful between that physical device and that digital one, right? So let's look at how I'm doing that. So here I have an RGB LED. You've seen it changing colors when the temperature was going above or below the max and mean values. I'll explain that a little bit in a second. But here I have a couple of functions, and these are the ones I'm interested in that I will look into. So the set RGB LED from cloud is a callback that I want the cloud to be able to call to get the device to do something. If I look at where this, let's find it, what is going on here. So in the setup function, I use the particle.function method to indicate to the cloud that there is a function called set RGB available on my device, and we'll point to that handle, which is set RGB LED from cloud. Okay, so now I'm declaring a function to the particle cloud. And if you want to look at this function, it's pretty straightforward. It's actually decrypting the string to retrieve the R, G, and B values that are shared as strings, as character. And then in the set RGB LED one, I will set the analog right for the 3 pins value to set the right color down there. Okay, so it's as simple as declaring a function pointing to a local handle, and the local handle does its work. Obviously returns a value to indicate success. And here I have this function here, set RGB. And if I want to switch, it's green right now. I want to switch it to blue, sorry. I'm going to do that. RGB call. The device will execute the function, and you will see that LED change color down there. Oh, there you go. Boom. And I receive the 1 and my LED change color. If I want to switch to, let's say, purple, for example, calling the function, boom, it's purple, and I receive the code here. So like an RPC, from the cloud to the device, exposed on the device to the cloud with only 1 line of code. Pretty straightforward. So the last concept, the last thing I want to go through with you is the notion of ledgers. So here we were able to send a message, receive a message, expose the variable from the device, expose the function for the cloud to call on the device. Now, if I want to share a more sophisticated state, not just one value or one message, and synchronize that state, basically report what I would call my reported state, and from the cloud being able to edit a desired state for the device to, be asked to change the mode, right? So let me go here in the ledgers page. So ledgers, there are 3 types of ledgers on the Particle Cloud. It is a mechanism that the Particle Cloud implements to synchronize a JSON file, several ones actually, from the device to the cloud. You do not need to understand the mechanism of synchronizing the file, sending the data, verifying the delta, whatever. Everything is taken care of for you by the Particle Cloud. What you need to understand is the fact that there are 3 different ledgers. The first one is a cloud only, a ledger that is only available on the cloud side of things, that the device cannot see, cannot read, cannot write, that only the cloud applications can see and consume and interact with. It's very interesting for exposing metadata for the device that the device doesn't need to know. In my case, you'll understand that with the thermostat example. In my case, I have an assigned user value and a room value. So that allows me to categorize my device, which is the thermostat, but itself, the thermostat does not need to know it in a specific room or with an assigned user. That's something that only cloud application need to understand and know, right? So here it's set up here in the Particle Cloud, and I can consume that from an application. The second type of ledger is the device to cloud ledger, is the ability for the device to report a state. My device has, as a smart thermostat, has a mean value and a max value for a temperature setting that allows me to say if I measure a temperature above the max, I need to cool down the house. If the temperature is below the min, I need to heat up the house. And if it's in between, all good, do nothing, switch to idle mode. So I want the device to report its actual mode. Is it heating, cooling, or idle? And I want it to report also what is the actual min and max value, because I want to be able to change it on the device or in the cloud. So I will report from the device my actual min and max values, and I will report the mode. So the cloud itself initially doesn't know anything about the structure of that JSON file of the reported state. On the device itself, I will show you how I'm preparing all of that and synchronizing that state. It's pretty straightforward, as you will see. So I have a notion of min and max temperature. They're local variables that will be updated from a command I receive from the cloud. And I will report these values, min and max, as well as the thermostat mode, which will be 1, 0, 1, 2, depending on the actual mode. So the ledger is initialized as an object of type ledger. I did create a function that will allow me to synchronize the states. So retrieve the value, and you'll see put them in the ledger, and then make the ledger available to the cloud. And I created a timer to do that on a regular basis. I want that local state of the device to be reported to the cloud every 5 minutes. Okay, so that's kind of my way of doing a keep alive. So now if I look at this little guy here, in the setup function, the one thing I need to do is to create a ledger calling particle.ledger with a name. That's going to be the name of that ledger, okay? Mark thermostat state. And in that thermostat state ledger synchronization function, what I'm doing is I'm creating that key value pair table or object, and I'm calling the ledger.set function, passing that collection of key value pairs. And that's my set of values that I want to synchronize, right? So here I have a new ledger available that is being reported when I call the set to the cloud with the value for min and max temperature and thermostat mode. So on the cloud side of things, I will look at the latest instance. It has a timestamp. It has the ID of the device that sent it. And here I have my min and max value for my device. And I can see the mode is 0. So it's in idle mode. And that is exactly what it is doing right now. It's on this idle mode. Let me switch the mode to, let's say, cooling by blowing on the device. No, you see the LED changed to green to blue, and here I see the mode is changed to 2, right? Which means it is trying to cool down the room because it went above the threshold, right? So here I have a new mode that has been reported from the device to the cloud through that ledger. Really practical, right? Last but not least, there is actually I'm going to stay on that state one here. Okay, so I still see these values. It went back to idle with mode 0. Perfect. I'm going to switch to this last type of ledger, which is the cloud to device. Here, I want to set a desired state for my device. So I have this cloud to device ledger that I want to push down to the device. Okay, so here my ledger is having a specific scope. It targets the device ID, which is here. I didn't talk about the scope of ledgers, but there's an interesting notion in Particle, allows you to have ledgers scoping a device, a product, which is a set of devices, or an owner, which is an even different scope. That's food for thought and certainly another conversation. My cloud to device ledger here is setting a new max temperature and new mean temperature, right? So this is, as you notice, the values you could see as right now set on the device. Now, if I want to switch to 30 and 25, the only thing I need to do is click set instance. The device will be notified there is a new set of settings for it to implement. So if I go back to my device reported state and that device to cloud ledger, I can see that it implemented the changes and now is reporting a new min and max temperature. On the device itself, what happened? So the same way I set the device to cloud ledger with one single function, in order to set this second ledger, what I need to do is call that one function, particle ledger, right, with the name, and attach a callback to implement some action when the ledger is updated. In that case, I call that sync callback function. And this one, what it does, it gets the thermostat config from the ledger. And so this function here is right here. And what it does a get. In there, reads for the values for min and max temperature. And then here I do the sync thermostat state ledger that I've been using to report the state earlier on. So I received a new command, I apply it, or the new setup, I apply it, and then I report that I did apply the new configuration. One thing you'll notice is that the Particle Cloud did not impose a schema on these ledgers. My own convention here is implemented. I check if I have this min temp and max temp value. I'm doing that manually, but I could have a schema and do deserialization of the JSON, reserialization, and so on. So that's your call. So we've seen really rapidly, how you can build a device twin using the Particle Cloud and leveraging its features, the publish and subscribe feature, the variable feature, the function feature, and the ledgers, which are now in preview at the moment I'm recording that episode or that demo, but they will definitely be part of the product. These features here are all you need to build a very rich and flexible device twin. So I hope you enjoyed this video, and see you soon. Bye.